our plan. That's our course has a lot of it's we just raise up some topics a bit not really upgrade, but in the last side we want to make a lot of application of the theory of optimization in many problem in management, in business, something like this, so that you can have an idea to use the optimization problem in our life. And as you know, that the thesis at the end of the program here, the program firm at the university, each of you have to make a thesis. And I can claim to you that half of the number of the thesis at the end of each batch like this, each class on each group, the number of, for example, at the end of this year, this semester, to the number of students who will defend the thesis at July this year, at the end of at this summer, then about 1/3 to half of the amount of the thesis, including at least one problem there, which is optimization problem. So I find out the minimum, the maximum of some function, mainly the linear programming and application, and that this problem come from all the problem in the thesis are real problem of some company or something like this, the stock market and every, but from 1/3 to half of the number of the thesis related to optimization problem. So the application of the topic optimization are diverse, and we study here just some topics, but a lot of things. The optimization in our program, including optimization 1, optimization 2, and also this cost decision making. Okay, that's also considered as optimization. In optimization problem, in the course of optimization 2, we have a problem of find out the shortest path. Mr. Kai, you are here. Quang Khai, you are
Yes,
there?
yes.
You learned optimization 2 already, and you know the network model. Is that okay? Network problem.
Yes.
In the chapter of network model, you have a problem of find out. You have a network, and we have a problem of find out the shortest path. Is that okay? Connect some nodes to another node. Is that okay?
Yes.
You still remember, I think. But if you look at our chapter PERT and CPM, so you said we also have a network. Is that okay? And from the start to the finish, you have network like this. And we find out the key point, one of the very important things here that we find out, the critical path. Is that right? Critical path is a path connect the start, the node start to the node finish. Is that okay? And the duration of each node, you can write the duration of each node to the arc. And you can consider as like a cast or something, or the length of this arc. Is that okay? Like the distance from this node to another node. I don't know if you know that you have something like this. You have a node B and the node C. Suppose that here is 5 and 7, and you have something like this. So that means that the duration of B is 5, and the duration of C is 7. Show you something. So you write down here is 5 here. You write down 5 here, and you can consider 5 as the length from B to C. Is that okay? And the critical path means what? Critical path means that the path from the start to the finish, and the longest one. Is that okay? Can you imagine?
Yes. Okay.
That's the longest one. And you have in the optimization tool, you have the problem of find out the shortest path. They find out the shortest, but here we have the longest. That is opposite side. Is that okay? So here in this, because we don't have an optimization tool here, but you are special. You study optimization tool first, but here we study the decision making, and then after that we study the optimization tool. So I cannot apply the optimization tool, the shortest paths algorithm to here, but for you, I think is possible. You see, you can apply the algorithm for the finding the shortest path, connect the 2 points. Now you can modify it to get the algorithm for find out the longest path. Is that okay? The critical path in the CPM method means the longest path. So you can apply the algorithm, modify a little to find out the longest path. Is that okay? And that is one of the that means that I mean that the relation, you have the relation between decision making, optimization 1, optimization 2, the three points of the triangle, and they are all optimization. Even and in this case, you see that the PERT-CPM problem here, we work mainly on the network, but it's also, in some sense, you can transfer it to the linear programming. And I tell you here, in this chapter, the next part, the part that we will study today, the part we study today, there is a way here to use the linear programming to make crashing decision. That means one problem in decision making, in a management problem that we are dealing with by this PERT-CPM. But one of the sub problem, one of the small problem inside the we call sub problem, there is find out the making a crashing decision, and that is also you can one of the okay. I teach you another way to find out the making the crash decision, but there is another way that reduce it into the linear programming and solve the linear programming. You solve the linear programming and you get the way how to crash the decision. Class decision, that the topic we study today. I just want to tell you two things. One, you should make a relation. We have three topics in our program. Firm is that optimization 1, optimization 2, and decision making. Decision making a bit more application of the application, and it raises up the knowledge. They give you the idea how to apply mathematics in our life, in management or something like this problem. That is okay. So what we study here, just some key points. A lot of points, but because our class is very crowded, and so I cannot divide it into a group to make presentation. But for the optimization 2 class, it's always about 15 to 20 students, then I can do that. But this semester, I try to make some of the presentation. The first presentation can be considered as not successful. Not successful. But now I ask you more effort to do that, and that is part of the final exam. Part of the final exam. So what does it mean? It means the final exam here, including two parts. The first part is the writing. Writing is the same as the midterm test. The second is presentation. Presentation, our class is about 43 students, so I want to divide it into 8 groups. One group is from 5 to 6 students. So the presentation, the writing here, 70 marks. And presentation 30 marks. So it's like this. So each group make a presentation, and the presentation will start very soon. Today we finish this chapter, and maybe next week I give you a free week for preparing that one. And the week after next week, so maybe 4 group we make presentation, and the week after next week, after, from the last 4 weeks, and each week is about you have about 30. Okay, 30 minutes, including questions, something. So you have to be very careful and prepare it very careful. And maybe one of the content of the topic here, including will be included in this. So the group will make presentation, have to try your best to get the marks with this part, but also the student also try to understand, because that is also part of our course, like an extension of the course. Okay, and at the end of this class, I will rearrange it. Maybe next week. Next week we come to the class like this, and then I will arrange the presentation for you. Topics, you will have 8 topics or 4 topics, maybe 4 topics, just so it's easier. 4 topics, and each one topic there are 2 groups will make presentation. So it's better for all the students in the class can understand carefully the topics. Okay.
Tự chọn nhóm được không thầy? Mình tự chọn nhóm được không thầy?
No.
Rồi em tự.
No. You should know that the aim of the presentation, one of the main aim, very important aim of the presentation is that I ask you, this is the application, I ask you learn how to work in a team. That people often call teamwork. Is that okay? You have to work in a team. When you finish the university, you come to work in a team in company. The team and company, all every people there 4 or 5 students, 4 people there, a sub member there, and you are the new one. Is that okay? You come to that group. You cannot choose the close friend to work with your team. No. So that's the reason why teamwork is one of the very soft skill for students. You have to learn the way how to work with the other people you have known before. Try to work with them. Is that okay? Learn how to work with them. And that's the way I will define it into into 8 group by just looking at this the list of the student here, and then group 1, group 2, group 3, group 4, group 5, something like this. But some group have a 5 students, some group have 6, because we have in all in the list is 44, but in the midterm test only 43 students in the midterm test. So I think our class is the real student in this class is 43. So 43 in 8 group, but means that about 3 group have 6 students. I will decide that this student come from which group. By the way, I have not yet marked. Maybe this evening, maybe this midnight, I will work till the midnight. And I think that at the midnight I will finish marking your class. But I have marked. So what is this? Oh my God! Something under it's the phone. The phone is automatically working. It's funny. I don't know why today I got a lot of phone from foreign company. It's funny. It's from Sri Lanka, from India, United States. Of course, I don't receive it, but a lot of things. And now the phone is certainly it's working. Funny. You wait a minute. I download this one, and you remember that I will check attendance, and the student come late 10 minutes or more, we minus 5 points. Even you are coming, but you are late too much, 10 minutes or more, minus 5 points. Just a moment. Yeah. I'm not yet finished, but many actually the exercises in the midterm tests are very easy, but especially some of the question, like the question 5 is exactly one example in the material I send you, but many of you cannot work on it. It's a pity you don't read material or something. And some of the others, for example, the first question, it's just minimax criteria for game, metric game, but many of you are not correct. It's so funny. Many are not correct. And especially the question number 3, the question about advertisement using television, radio, and what media or something like this. Many of you are not correct. Actually, you don't know how to establish. The problem is a game theory. It is a game problem. It's pity. That's you. But the exercise in the book, exercise in the chapter I send you. But it seems that many of you never work on this. And some of the exercise there is just an example, exactly example in the book, in the chapter I send you, not in the other books. In the chapter I send you, example. I just modified a little bit, but the mark, I tell you, your mark is very low, very low. Okay. So, but I tell you that I tell you about this situation. I just want to mention you that if you want to pass this course, you have to study. Is that okay? Study. Everything is very easy. Everything is very easy, but you need to understand. I take an example. I take an example like some game. Is that okay? Game like this. Solve the game. You have, for example, B1, B2, B3, B4, or something like this, and then A1, A2, A3. And now you have some row, some column like this. And you have, I make the first question. Let's look at the first question. Here. Minus 8 is minus 6. Minus 8 minus 6. Minus 2 minus 8. The second one, minus 8 minus 9. And minus 4 minus 5. Is that okay? And minus 7, 5, 3, 5. Minus 7 minus 5. Minus 3 minus 5. And the problem like this. Is that okay? You have the game, this game. And the payoff is for the player A. Player A, player B. It is the payoff is for player B. And just want to solve this problem. Is that okay? Solve this problem means you use a minimax method. Minimax method means what? For each strategy of each player. For example, for the A1 here, for the strategy A1, you find out the minimum, the worst. Is that okay? The worst. The worst of A1 is what? The worst A1 is what? Is -8 or -2? Two things. -8 or -2? Nguyễn Anh Thư. You say, what is the worst of A1? Anh Thư, you are there?
Yes, I'm here.
What is the worst for player A when he use A1?
The worst is
There are two things. -8 or -2. Which one?
-2.
-2. Okay, Hà Uyên, you are there?
Yes.
So up to you.
Yes.
The worst of A1 is what?
So I think the worst of A1 is B3. A1 B3.
A1 B3. So that means -2. You mean?
Yeah. Yes. So that the least that A can gain is 2 and B can lose 2.
Yeah. So for the A2, Uyên, A2, the worst is what?
A2 is a B3.
That's
The
also
same.
-4. You mean?
Yes.
And then A3
Is -3.
-3. So you mean this one is what? This thing is what? Is the maximum of the row or the minimum of the row?
Is maximum of the row.
Yes. It is the maximum of each row. But in my example, it is minimum. Is that okay? And so I see many of you find out the minimum. And the minimum is what? The minimum here is a -8, and here is a -9, and here is -7. Is that okay? You find out the maximum here. So that means the worst of A. And about the worst, you find out the best. The best among the worst here is what? Quang Khải, okay, you. The best of the worst in for A is what? What? A1, A2, A3.
A3.
The best among the worst of player A is what?
9. No, -9.
No. I don't know if you follow what I'm saying here or not. The minimax, the minimax criteria. So means that
-4. -4. Sorry. Em nhìn nhầm. -4.
Yeah, that's right. The best, this is the worst, and the best from this is this. So that means what? That means in this case, when the player is a player, when the payoff is for B, and then you find out the row in the row here, A1, A2, A3, you find out the maximum, and you find out the maximum, and then you find the There's max min. And for the player B, so in each of the column like this, you find what? Max or min. This is for player B. Is that okay? For player B, then the worst is what? The worst is, for example, B1, -8, -8, -7. So the worst is -8. Is that okay? This is for B. You understand? This is a payoff for B. So the lowest is the worst. So it is -9, -4, and then -8. The worst. The worst here is means that here you have find out the minimum. And you find out the best among the worst. So what is it? It's here. Okay. So you find out the maximum of the minimum. So this is because here is the payoff is for B. And then we find down here. So you have to, I just tell you just one example. But what you study is just, okay, you have like this, then you have a min and then max. And then here is max and then min. You don't understand anything. That's not correct. The idea is each of the tree, we find out the worst. And among all of the worst, you find out the best. So that is a pessimistic idea. Pessimistic idea. We choose the best among the worst. And that is the key idea. So based on this, you can work with the game where player is for A, player is for B. It's okay. I see some of you are not understand like this, but it's still intelligent. Because here is a payoff for player B. You don't know how to work on it, and some of the students change it to payoff for A. Okay, you change the payoff for A by changing all the sign here from minus to plus, from plus to minus. Is that okay? Play for A, and then you find out in the column, the last column here. You do the same as my example. That is the min and the max. And here is the max and the min. That's okay. Because that is for player A. So the numbers here, every elements here is the payoff for B. Just a very small just show you this, so that just to mention you that you are a student of mathematics. You have to learn and you have to know about the idea. Some of the example very easy, like the question number 2. Question number 2 is just what is the recommended action for Hank when we use Laplace criteria, Minimax, Hertwig's criteria. Laplace, Minimax, Hertwig criteria. It just Minimax is what, but many of you cannot work on this exercise because you forget. You don't remember, and you don't understand very clearly something like this. And for example, another question B is that dividing the score for passing letter A, B, C, D, and that is 90, 80, 70, 60 respectively. Suppose that Hank is more interested in letters rate. He will get he prefer A or B. That means 80 or 90. Okay, prefer A or B. Would this attitude Hank call for a change on his action proposed in A? You see, in my example, we don't have that. We just have Laplace, Minimax, and Hertwig's. Is that okay? And we don't care about the value of the game. So he prefer 80 or 90. So that means that you may use a Minimax or Hertwig, or for example, but the number on this table is the number of marks. So for example, for the Minimax, if you apply the Minimax, the value is 88. So that means that is a good choice, because 88 is from 80 to 90. That is from A or B. That he get B. That is okay. Is that okay? Then in that case, for example, he also can choose if the value of the game may be 88, and if you choose a B2, and then it can be 84, and then it can be choose two things. 84 is okay. 88 is okay. Still okay. So each of the question like this, I always want you to think, to understand the idea. Is that okay? And the question number 3, most of you cannot work on it, or some of you is working on it, but so wrong. So by the way, I give you some hint for the question number 3 too. Here.
Bài ba trong lớp có ai làm đúng thầy?
Because I have not yet marked in all, so I don't know. I will finish it.
Nhưng mà thầy thấy ai làm đúng như thầy? Thấy ai làm đúng như thầy?
What do you do? What do you do with the exercise number 3? Let me check your paper.
No.
So don't worry. I see here the question number 3.
Thôi thầy cháu lần cháu không khai. Ghê đó.
No, nothing special. That is. You haven't. You don't work on it. The question 3.
Có thì em có làm thầy.
Yeah, I see. No, not correct. Let me. You have worked on it, but that is not correct. So let's see like this. You have 2 companies promotes product. Currently, each company product control 50%. So because of recent improvement, they need to make more advertisement, and the key number is this. If you use if companies use if you use television for advertisement, and then you can get 50% of the customer, potential customers, and 30% to the newspaper. And but if you use radio, and then the just 20%. Is that okay? So each company can choose among the three ways. Is that okay? Each company can choose 3 ways. So you see like this. You have 2 company. Company A. Now here company B. Company A. Okay. And you write down here. You have a television, newspaper, and then radio. Is that okay? And the company with the same. They have a 3-way: television, newspapers, and radio. This. Is that okay? Now suppose that A use a television and B use a newspaper. And what happened? A will get about 50% potential. Is that okay? But B only can get 30. A use television. Listen. A use television and B use newspaper. So what number here? Suppose that we can make the payoff is for A or B. So let's say payoff is for A. So in this case, A gets 50% and B gets 30%. So here is 20% for A. A gets 20% more than B. Is that okay? If A television, but B also television, so 50-50. So no one get from the others. Is that okay? Nothing. So 0. If A television, but B radio. Television 50%, but radio is only 20. And then the excess from A from B is 30. Is that okay? Here is the percentage of the market. Something like this. If A use radio and B television, then radio is 20% and television is 30%. And then here is what? Okay, here is what?
Here là chỗ nào này? Em chưa thấy.
A use radio. No. A use radio and B use television. Then here is what?
Zero.
That means B gets 50% of customer and the A gets only 20. So that means A is less than B 30%. Is that okay? And by such a way, you have something here is minus 20, and here newspaper, both get the same 0. Here both get the same 0. So by this way, you have the table, that matrix of the game, and the payoff is for A, and you can use the minimax theorem. Min here is 0 or something. Of course, you can work. That's so. The key point is you have to work with example. You have to read a lot of example. At first, and the second, work with some exercise. These things are all the material I send you. So I have to think of it.
Ủa thầy cho em hỏi xíu là nếu như cái payoff của em tính kiểu khác được không thầy? có giả sử như là TV nó hơn newspaper thì em cho nó số 1 luôn, có nghĩa là mình do là cái đề trong đó nó đọc thì nó ý là cái đề của cái bài 3 thì là nó bị hiểu nó rất nhiều nghĩa, thì em đọc đề xong rồi em bị hiểu nó nhiều nghĩa lắm chứ không phải.
Understand.
Đó là theo em hiểu nó giả sử như thằng TV mà nó hơn newspaper thì thằng A nó sẽ lấy được hết luôn thị trường của thằng B, cho nên pay off của thằng A lúc đó là sẽ là 1.
No. No.
Đấy là theo em đọc em hiểu vậy thôi.
Listen. Television, if you use television, you can get 50% of customers. But another one use television, use a newspaper. He can get 30. You get 50, but they get 30. No problem. And if you say the pay up is for A, then you are better than the other 20. You get more than the other 20%. That's all.
Nhưng mà nếu như làm kiểu em á thầy, thì cái đáp án là hai bên chọn TV nó vẫn đúng với cái đáp án này luôn thầy. Có nghĩa là theo em đọc đề, theo em đọc đề em hiểu.
If you make wrong thing, but the result is the same, then we cannot. It is eventually.
Không phải wrong này, nhưng mà do cái đề làm cho tụi em nó hiểu theo nhiều nghĩa, chứ em không có hiểu theo nghĩa này. Em đọc thôi là em hiểu là.
So what is the meaning you understand? What the meaning you understand?
Thì nếu như thằng A nó dùng TV mà thằng B nó dùng newspaper thì thằng A nó sẽ lấy hết thị trường thằng B luôn, cái là thằng A nó sẽ win luôn. Cho nên là thằng A đó em cho pay off là một.
Làm sao được?
Còn nếu hai
làm sao lấy hết được? Nó chỉ lấy được 50% thôi mà. Trong cái đề nó nói rõ là nếu anh dùng TV thì anh chỉ được 50% thôi mà. Còn thằng B nó
không thể trong cái đề này có cái số là proportional percentage, cái từ đấy rất là khó hiểu này.
Tức là khách hàng tiềm năng thôi, là 50% thôi. Còn thằng kia dùng cái newspaper thì chỉ được 30% của cái khách hàng potential của nó thôi. 20%, 30% là của cái market. Hiểu không? Chứ có phải là lấy hết đâu, làm sao lấy hết được.
Nhưng mà trong đề thì là thầy lấy cái đề gọi thầy cái chỗ proportional percentage thầy là hai từ đã đồng nghĩa với nhau. Chừng thầy ghi hai cái sát bên nhau thì làm cho em không có hiểu theo cái hướng đó, không có hiểu theo hướng này được. Cái từ proportional với lại cái từ percentage là hai từ đã đồng nghĩa nhau này.
Cái tỷ lệ phần trăm mà tiếng Việt mình dịch là như thế chứ sao là hai cái giống nhau được.
Không thầy. Hai từ đó là bằng nghĩa nhau thầy. Nó đều là tỷ lệ thầy. Proportional với lại percentage là như nhau thầy. Đồng
Em
nghĩa
tra
nhau.
thử từ điển chữ percentage là gì? Percentage là phần trăm chứ làm sao có tỷ lệ được. Percentage là phần trăm, cent là trăm. CENT là chữ cent ở tiếng Pháp là 100. Mà nó ghép vô là percentage, nó lấy cái từ tiếng Pháp nó ghép vô percentage. Percentage là phần trăm chứ làm sao có proportional là tỷ lệ. Percentage là phần trăm. Có cái từ điển nào mà
có này. Để em xem thầy. Do hồi xưa là em học IELTS thì hai từ này nó đồng nghĩa với nhau mà. Đây.
Không.
Em xem hình.
Nghĩa với nhau được.
Đây.
Khi nó viết với nhau như này thì phải hiểu là tỷ lệ phần trăm.
Không, thì hai từ đã đồng nghĩa nhau.
Để mình tra từ điển.
Đây thầy em để đây. Cho nên là em mới không hiểu, em mới không hiểu là cái từ đó như thế nào á.
Hiểu thì chịu thôi chứ.
Không thầy, ý là
tỷ lệ nhưng mà phải hiểu là tỷ lệ phần trăm chứ không phải là tỷ lệ thừa thôi. Percentage người ta hiểu tỷ lệ thì cũng là tỷ lệ phần trăm thôi chứ làm gì có chuyện. Cái đề nó là nguyên si ở trong cái sách từ ta ha, trong cái chương tôi gửi cho các bạn ấy, chứ tôi có sửa gì đâu. Sao sai được. Tiếng Việt, rất Việt. Anh này, nó có tỷ lệ phần nhưng mà cái nghĩa của nó là tỷ lệ phần trăm. Khi mà ta có viết chữ proportional percentage thì rõ ràng là chữ tỷ lệ là phần trăm, chứ không sao nói chịu, hiểu sao thì chịu. So you see that the percentage, see the, đương nhiên một chữ là nó có nhiều nghĩa, nhưng mà ở chỗ nào thì hiểu như thế nào. Chữ này, cái chữ cái đề đó. Người ta viết ở trên đây phần trăm hết này. Nè, each product control 50% of the market. Rồi dưới này người ta nói là percent, người ta viết hết chữ percent cho này. Nè, that 50% are potential customers. 30% through the newspapers, 20% through radio. You are wrong, Khải. Okay, so it means that I just want to tell you, it means that the skill of working in exercise like this need practice. If you don't practice, you just learn this topic by reading, by using your eyes, and it's no use. It exactly like an example I tell you here. If you just read by eyes and then you don't understand, you have to practice. There is some exercise with the payoff is for A, another exercise payoff for B, examples in the book or something like this. So you know. Then okay. If you don't want to think, you just read example of the books. And and one of the example is very funny. It's exercise is exactly the example in the book about the sell the land or reef for oil or something like this. Very easy, but many of you do not work on it. Very easy to get marks. Exercise like this, 25 marks. Okay. Hello. Khai, you have any other idea? You see?
I have no idea.
No.
nhưng mà em hiểu kiểu khác cho nên là cái vẽ khác, nhưng mà cái đáp án vẫn như nhau này. Cái gì thầy chăm trước thì đừng trừ hết nha thầy.
Let me check. Let me check. But the result is the same as for example, you see that the exercise number 2. Is that okay? About the Mr. Hank. If you use if I ask you to use the minimax criteria to advise him which strategy he will choose, then the minimax show that A3 is good. Is that okay? It's the best for him. But Hedwig's. But if you don't know what is the minimax, you use a Hedwig, and you also come to the answer is A3. Then you cannot correct. You understand? I cannot give you any marks because you use the wrong method. It's not the method I mentioned you. And of course, you do some any question I give you the solution, I always give step by step. For example, the question number 3, the first one is the game model, matrix game model. You transfer the problem into the model. That's the first thing. Is that okay? I don't know what. Let me see. How many? There are 15 points. But the solve the game is very easy. Minimax, very easy. 5 points. So the modeling 10 points. And the minimax is just Very easy. And then okay, find out the mean of the row and the max if the payoff is for A. And now you make a pair for A. That's very easy. And the answer, of course, both should use television. That okay, and each of them get a 50%. Okay, so now we continue with the last time I tell you that we find out the critical path is 44. And the deadline is 47. Is that okay? And so you see here, the formula are here. The formula is here. D is the deadline is 47, and the mean, the critical path length is 44. And then you have K alpha, and then after all, you find out the probability that Mr. Purdy can finish the work under after that's less than 47 weeks is 84, 0.84. So what does it mean? It means that large parts, 85%, that he can finish in time, within 47 weeks. Is that okay? And the problem, I find out the probability that he can complete the work in 3 weeks, instead of 47 weeks, that is okay. That's high percentage, so it's okay. Sure that he can finish it. But in the condition of the work is like this. If you can reduce the work to 40 weeks, then you can get $150,000 for bonus. 7, the normal time, the mean time is 44. Is that okay? Now, if you can reduce just 4 weeks, then you can get $150,000. $150,000, you understand? That is more than 3 billion Vietnamese dong. That's a lot of money. Okay. And so now he thinks that, okay, let's see if we can reduce 4 weeks or not. Is that okay? If we can reduce 4 weeks, and then we can get this one, get this amount. But you remember, if you want to reduce the time, and then by what sense? We have to hire more workers to or improve or use some kind of modern techniques or something to reduce the time of the duration of some nodes. Is that okay? But each time you do like this, you reduce 1 week at node J, for example, you have to pay some more amount of money. Is that okay? So if you reduce 4 weeks, first of the 2 questions, the first one, which nodes you should reduce? Which node, with activity you should reduce to get the cheap price? Is that okay? And a node, you reduce that one, the reduce, and each node, how many weeks we can reduce? Is that okay? And in that case, you he have to hire a group of experts to calculate anything about this. And after that, if we reduce this one, he have to spend some amount of money. You understand? He have to spend some amount of money. And the money he gets, after all, when he reduced to 40, of course, not the whole 150, but minus some amounts of money he spent to reduce the time. For example, he spent 100,000 to reduce 4 weeks from 44 to 40. Then the money after all he can get for the penalty is $50,000. Okay, $50,000 is also a bit amount, considerable. It's a billions of Vietnamese dong, and it's worth working. Okay, in that case, he think of reduce the time. And the part of our lecture today is give you the way, the idea, how to reduce it, and how to calculate the cost. The cost of reducing 4 weeks. Okay, how to calculate the number $100, $100,000 here. And the idea is in the follow. It is very easy. Okay, I'll tell you. He may think of reduce to this to get the dollars. That's the idea. If an extra money is spent to expedite the project, what is the least expensive way to attempt to meet the target of completion 40 weeks? That is called the part of time cost trade-off. Time cost trade-off of CPM. Okay. So the subject time cost trade-off of the CPM method. And the tool we use, if you have a complicated problem, you can use they can transfer this problem into linear programming, and you solve the linear programming, and that is one of the topics. Topic of the final exam. One of the 4 topics I tell you. So I don't teach you this. You must do it as a final exam. Read. That is just about 1 page or something, but you understand and represent it. But I tell you some more way, another way, not this way. We do not study here. The time cost trade-off for individual activity. First of all, we divided the question to reduce the project into 2 things: crashing one activity and crashing the whole project. Crashing each activity, so it means that we have to consider to calculate each of activities we can reduce. For example, this activity C, 10 weeks. How many weeks is the maximum that we can reduce? For example, 2 weeks. Okay, 2 weeks, and the money we have to pay for reducing 2 weeks, how much? For example, $100,000 for 2 weeks. Is that okay? But sometimes we don't want to reduce it because this is a very expensive. I can reduce 1 week at this activity, and another activity, if it's cheaper, I remove 1 week. 1 week there, 1 week here, or something like this. So each activity, we have to find out the cost of reducing 1 week. How much we have to pay for reduce 1 week, and how many weeks at this activity we can reduce. Some week, some notes we can reduce only 1 week, but some other note we can reduce 2 weeks or 3 weeks, something like this. That is the question one activity. And crashing the whole project. The whole project you want to crash to reduce it into 4 weeks, from 44 to 40. So crashing the project, you have to consider something and find out which node we should crash. And in this note, we should crash 1 week or 2 weeks or how many weeks in each of this. For the whole project like this, you know that the longest path is but by the way, the longest path is the critical path. Is that okay? Critical path, the longest is 44. So if you want to crash the duration of the project, that means you want to reduce the time for finishing the project, you need to consider the critical path. Is that okay? You have to reduce the critical path. By the way, I tell you, there is one topic, maybe I will give one more topic because I think of this. There is a way to modify the shortest path problem to find out the longest path problem. Longest path problem is find out the critical path for the CPM, PPERT and CPM. And that is also easy way. It's the shortest path or longest path is very easy. And I think that here in our group, here is Mr. Kai is already study about the shortest path problem. Mr. Kai, I ask you. Hello?
Hello.
Okay, so do you still maybe you forget, but if you read again and then you think that you can you understand the shortest path problem and the way how to solve it, the algorithm?
Yes, maybe, but I have to read it again.
Yeah, you read it again, and I think that you understand. And I propose you that I don't know now you are in what group. We have 8 group. You may be in one of the group. Is that okay? And then I just want to ask you, if you are in one group, like a group 5, for example, you are in group 5, and then I ask you that you can teach your friend about the shortest paths. It's easy, just half an hour. Very easy. You have the graph, is that okay? And you teach them the way how to find out the shortest path. You remember from A, and you find out all the nodes that can be connected to this, and you find out the shortest, and you go to C or something like this. That's very easy. And you go from A to N or something like this, the shortest path. And you teach your friend in the group understand about the shortest path. And from that, all of you in the group can modify it and make it into the transfer that, modify that method to solve the problem, find out the longest path. You think that you can do? Of course, I can give you some material about this, but you can think that you can do that? You have the ability to tell your friend, understand about the shortest path problem? You have the slide of that group of people. That's right. I think so. If you don't have, I can send you back that the slide and the report of the group in optimization tool that make the presentation on this. I remember that time very easy, and they just talk and people in the class understand it.
I'm not sure.
So now, from I need your answer next week. You come back and take a look at the shortest path problem. You see, from now to the next Wednesday. And if you see that it's very easy, I can tell my friend, in the group understand that, then I will ask your group making this. Find the shortest. Find the shortest path means that if you have the program, if you have the no, you have some. Find the shortest path means that if you have the PERT model like this, you can apply that method to find out the critical path. Is that okay? Because I teach you this, you find out the critical paths anyway. No, we just find out one path from A, B, C, D, G, H, M, and finish one path. Another path A, B, C, E, and H, M, finish. A, B, C, or something like this. You list, and the longest is the critical path. Okay, you see? But
thầy hay là để ý khác được không thầy? Do mấy bữa nay em hơi bị áp lực kiểu làm thesis rồi mấy môn kia nữa thầy, hay là thầy có thể cho một cái project mà nó vừa sức hơn không thầy? Do là thật ra bỏ thời gian ra giảng với bạn cũng được thôi, nhưng mà ý là nó sẽ
if you don't like, so no problem, no problem. I think that's very easy. It didn't take you much time, but it's useful here. I mean, that's right. All the other, if you work in other subject, it take you the same time, no problem. But if you don't like, no problem. No. So forget it.
Oh yeah, I'm sorry about that.
That's no problem. It's not hard. It's the same. The difficulties level between the topics are the same. I think it take you very not much. You can. It's all the topics I tell you that is easy. It take at least time, very few time. Okay, so in order to reduce the time, you have two steps. The first is a crash. That means reduce the time for each activity. Is that okay? At each of the activity, you have to calculate how many weeks we can reduce, and if we reduce 1 week, then how much money we have to pay. That's for one. And for the whole project, you have to reduce the longest paths. That means you have to reduce the critical paths. And for example, critical path is 44, and now you want to reduce into 40. And the critical path, you have 10 nodes. So for the whole project here, which nodes should we reduce? This critical pattern A, B, C, D, K, N, L, or something like this. So which one we should reduce? And in each of nodes, we should reduce how many weeks we should reduce for this. Maybe this node we reduce 1 week, and now the node we reduce 2 weeks or something like this. Is that okay? And so that is two equation for this. We crash the whole project, divided into 2 parts, like this. And then now for one, we need to make some assumption. Suppose that this is the normal time, and this is the normal cost. The time here, the cost is here. The normal time here, for example, 10 weeks. Is that okay? And the normal cost of this, up the, like this. You see, for example, the cost C, the node C, 10 week. The normal time is 10 week, and the cost for realizing this is, for example, here is $200. In order to finish this, we need $200. That is not in the in the table we have before. In the table we have before, we don't have the money here. But now, if you want to crash, you need to calculate this. Okay, but the calculation is not easy. It's not hard. It's easy. You know that 200. And now you have to calculate like this. If you crash, instead of 10 weeks, you crash it into, okay, here is 5 weeks, for example. You crash to 5 weeks. So that means that the time, the normal time is here. The crash time is here. So in this case, how many weeks you reduce? 5 weeks. Okay. And what is the money? The money, if you reduce it into 5 weeks, then what is the crash cost? That means the total cost for you to reduce into 5 weeks is what? For example, here is $450. $450. And then how can we calculate? Because we need this. This is the calculation for reduce 5 weeks. But for example, in our project, you see that we need to press 5. 4 is enough. Is that okay? And so, but the way we do is that we want to calculate if we reduce 1 week, then how much we have to pay. 1 week, then how much we need to pay. So let's take a look. We have something we call assumption. In this we make an assumption that is the cost of question here following the linear rule. The linear rule means that from here to here is like this. 5 weeks. If you reduce to for example, if you reduce here to 6 weeks, that means you reduce 4 weeks. Then the cost is here. You understand? We assume that the cost here is linear. If I want to reduce just 5, 6, 7, here is 7. That means I just want to reduce 3 weeks. And then the cost I have to pay just like this. Here. The cost is here. 3 weeks, then the cost is here, not 400. Is that okay? And then it means that in order, if you have like this, then the way you have $45 and the difference between the base cost. This is the base cost for the normal cost. The normal cost for the normal duration is 10 weeks is 200. Is that okay? And this is for the reduction is 5 weeks. So 1 week is this. That is the assumption. We assume the crash cost is linear. So that means we calculate for the reduction for 5 weeks. Is it 5 weeks is this one. The cost for 5 weeks is 250. Is that okay? And this is the cost for reduction of 5 weeks. So 1 week is just divided by 5. That is the linear. Okay. That is one assumption. Assumption that the crashing cost is linear, so that we can we make a reduction. For example, this note we can reduce 3 weeks, and the money we have to pay is 3 weeks. We have to pay $300 or $300,000. So if we reduce 1 week, then $300,000 divided by 3, and then we have $100,000. So each week, $300,000. That's the way we have the crashing cost for an activity at each week. Okay. So in order to do that, this is the way I tell you, that is before. We reduce from 8 weeks to 6 weeks, and then the money is raised up from $403,000 to $409,000. So it means that it is the total money here is $60,000. But in 2 weeks, so 1 week is $30,000, like that. And in order to, of course, in order to calculate the crash bond, crash cost or something like this, Mr. Perry have to invite a lot of experts come to calculate for him each of the activity, and the cost of expert and the cost of the worker, the cost for it, every cost included in this to reduce this 2 weeks is this. Every cost is included in this. The cost of hiring the engineer, the experts come to calculate or something, and the cost of paying for the extra time of the worker, extra worker or some anything. It's raised up from 4,300 to 4,900, and that means that $60,000, and within 2 weeks. So each week is this. Okay, that's the way of calculating. After doing that for the whole project, Mr. Purdy have the table here. This is the normal time. Normal time, crash time. And you see the for example, the note D, normal time is 6 weeks. Rest time is 4 weeks. So the time you can reduce is 2 weeks. Is that okay? 6 weeks you can crash into 8 weeks, 6 weeks into 4 weeks. So the time you reduce is 2 weeks. And the money, it's the normal money for this note is 260, but for the crash, that means for reduced 2 weeks, the money is this. And so the total is $80,000. And you reduce 2 weeks. So 1 week is this per week. 1 week is that. Is that okay? 2 weeks, this. 2 weeks, 80,000. So that is 1 week, you have 40,000. Okay, that is the way we calculate. And then, for example, the note J is 8 weeks, but the expert come and say, okay, this note we can reduce to 6. So that means with this note we can reduce 2 weeks. We can reduce 2 weeks, but the money is about $430,000. Now it's come $490,000. So it increased. If you want 2 weeks, the money increase here is $60,000. Is that okay? And you reduce with $60,000, you spend you can reduce this note 2 weeks. So 1 week is $60,000 divided by 2. So for all the notes, so Mr. Purdy have to hire the expert to calculate this for all the notes like this. Is that okay? Up that. But if you sum up here, if you sum up the money here is 455 billions, but the crash here. But if you calculate all the sum of this, and then it becomes 6.15 millions of dollars. It sounds impossible. That is so much money. That okay, but not like that. Not like that. Not all of the nodes we need to crash all of the nodes, and with each node you can crash 2 weeks, 4 weeks, and something. For example, in some of this 3 weeks or something like that. You don't need to crash all of this. You crash some of the nodes. It's enough. And very reasonable. For example, in the which nodes we should think of reducing. I tell you already, but I just want to ask you if you remember. Among the graph like this, project, which nodes we should think of reducing the cost. Hello? Hello? Terrible. You you have to I don't know if you follow or not, or you just watching something else or something, but it's so easy. Take a look. You see here, we have here the critical paths. This, 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 this. The critical path is this. And the time is, the duration of this is 44 weeks. But among them, among this project, we have a lot of other paths here. All the paths and the length of paths. You have the paths A, B, C, D, G, H, M. The length is 40. You have these paths. The length is 31. The length 43. The length 44. The length 41. The length 42. If you want to reduce it, to reduce the project, the duration of project, the longest is 44. And then the first of all, if you want to think of the reduction of the length, so we should think of we should think of the length of the reduce the length of the critical path. Is that right? Because the longest and the duration, the longest path is the duration of the, also the duration of the length of that is also the duration of the project. If you want to produce the time project, first of all, you have to think of the reduction of the nodes in this. Is that okay? So what are the nodes? The node in this is, I'll write down here, A, B, C, E, F. Where is it? Where is here? A, B, C, E, F, J, L, N. J, L, N. So take a look here. What are the nodes that we should here? The nodes we can think of reduce the time first are the node on this A, B, C, E, F, J, E, L, and N. Is that okay? These nodes I write down here already. So, but we should take a look at this table. The time here. Is that okay? I delete all the thing I write down here. Oh my God. So you see it easily. we take a look at the cost. Is that okay? A, B, C, E, F. A here, B here, C, E, F, A, B, C, E, F, J, L, N. L here, N here. Is that okay? So you see in this note, which one we should reduce? First of all, we think of A, B, C, E, F, J, L, N, because it's in the critical path. If you reduce 1 week, then the length of the project will reduce 1 week. Is that okay? And so if we want to reduce the length of the project, we should reduce one of these nodes. And among these nodes, which one we should reduce? Very easy. Okay, it's very natural. You look at the crash cost. Crash cost. If you reduce A, you have to pay $100,000 for 1 week, just 1 week, $100,000. If you reduce B, 1 week, $50,000. C, $80,000. E, $160,000. F, $40,000. J, $30,000. L, $50,000, and N, $60,000. So which one we should reduce? Very easy. The least, the cheapest. Is that okay? The first idea, we reduce the cheapest. The notes, that is cheapest. The cheapest here is what? 30. 30. The cheapest notes that we can reduce 1 week is 30. J. Is that okay? J. We can reduce J. And we have to pay only $30,000 for 1 week. Okay. And you remember J, you can reduce at most 2 weeks, but it's possible you can reduce it into 2 weeks. And so now we come to this. Look at this table. We have another table. This is the original. The original. That there are some paths. One, the first path, second path, third path, fourth path, fifth path. We have 6 paths. And here, for example, the last path is 42, and then the original is 42 here. And the critical path is 44 here, and then this is 44. And the beginning is 44. Okay? And now if you reduce J, you remember, I see that J is the cheapest. I reduce J, crash J. Crash J 1 week. 1 week. No. I crash the node J and 1 week. That okay? And then the critical path here become 43 weeks. Is that okay? 43 weeks, but when the node J, look, the node J here, the node J here is 8 weeks. The node J is 8 weeks. And now you reduce 1 week, and then it becomes 7. Is that okay? It becomes 7. And when it becomes 7, the other path is also reduced. Other paths which passing J also reduce 1 week. So we look at this. We look at this. Which path contain J. This batch contains J here. Is that okay? And so it's reduced 1 week into 42. And this batch contains J, and so it's reduced 1. And this batch also contains J and reduced 1. Is that okay? And so the length of here, look at this row, the second row, and you see the length of all the new batch are this. If the node J is reduced 1. Then okay, and then all the nodes, the length of the paths no change. You understand? All the other paths, all the paths is go this way, no change. I just reduce the duration of the J, and then we still have a six paths, and the length of the paths in this case, when we reduce a J like this, become this one, 40, 31, 42, 43, 40, 41. And this one is still the critical path. Is that okay? This still critical path, and it's longer all the other paths. Then if you want to reduce more, you reduce on which nodes? We should reduce some nodes still in the critical path. But you look again here, or node in the critical path here, and look at this table. Still the node J. Still the node J is the node cheapest. And the possibility for reducing the time of this is 2 weeks. So you reduce 1 more week at J. Okay? We reduce 1 more week at the node J. We reduce the node J again 1 more week. And the money we have to pay is $30,000 more. And the same as before, all the paths which contain J still reduce 1 week. So this one, 32 now become 41. The critical points, the critical paths here, 43 now become 42. And the path number 5, 40 now become 39. The path number 6, 41 now become 40. And so you see this is the length of all the paths in the new situation that we reduce J 2 weeks. That okay? And of course the money we have to pay until now is $60,000. Is that okay? $60,000 we reduce 2 weeks. Is that okay? And still the path number 4, the path number 4 is still longest, and that means it's still the critical path, and the duration of the project now is 42, and this is still the longest path, the critical path. And so we look back at the critical path again. You see, you have these nodes that are okay, and we reduce this node already from 7 and 7 to 6, and no more, because the node J can reduce 2 weeks and cannot move more. And so we look back again at this node in the table, see which node is still can be reduced, but the cost is very cheap. The next one here, you see all the nodes in critical path are now A, B, C, E, F, J, L, N. And among this node, we don't care about this anymore. Is that okay? Because you can reduce 2 weeks, and I do it already. So we cannot reduce more on J. But so now we look at A, B, C, E, F, L, N. Which one is cheapest? 60, a lot. 50, a lot. A, 100, a lot. B, 50, C, 80, E. 160, and F 40. So now you see the node F among all the other nodes in the critical path. The node F is the node that if you reduce it, then cheapest cost $40,000. And now, how many weeks? Okay, it's also, you also can reduce 2 weeks on this. And so if you look at the table we have here, that is 42 weeks. Now, if you reduce 1 week, if you reduce now you reduce F. You reduce 1 week and then you get this one, and you reduce 1 week more and then you get 40. And 40 is the limit time that we need. And you reduce the node F 1 week, 2 weeks, you have to pay more, $80,000 more. And then after all, you see there, in this case, if you reduce F 2 weeks, and then you have like this, and you have 2 other critical paths, but the critical path is also 40 weeks. So that means that the best way for us to have a cheapest cost for crashing the whole project is reduce J 2 weeks and reduce F 2 weeks, 4 weeks, and the total money we have to pay is what? 60,000 plus 80,000. What is it? 80 plus 60 is 100. 40.
140, yes.
So you see, you can reduce into 40 weeks, and then you get you have to pay $140,000. But if we look at the condition of the project, when we sign for the project, that's if you reduce to 40 weeks, then you can get $150,000. Actually, we can get $10,000, but is it worth for doing that? What do you think? You make a lot of effort to just get $10,000. It's worth of doing that?
No, it's not.
No. Yeah. No, it's not. It's not worth of doing this, because when we reach to 40, and then we have to pay a lot of money among the bonus. So we just get $10,000. Not worth doing that. One reason for not worth doing that is what? One reason is the bonus is very little, $10,000 among the 4 billion or something like this. But still, there is another reason. What is it? I think that actually your mark is low, is really reasonable. You don't study at home before coming to the class. Did you take a look back at the lesson last week or something like this? Have you do it? Have you done it? Hello? Kim Thúy, okay, Nguyễn Kim Thúy, Kim Thùy, I don't know, because here don't have the Kim Thúy, you are there? No. Nguyễn Lê Hồng Ân there?
Yes, I'm here, teacher.
Have you look at the lecture note, at least the lecture notes I teach you last week for before coming to the class today? No?
Not yet.
Okay. I hope that, because the question is very easy, but no none of you can answer. So I see that you never look at it. One thing is that 40, you reduce time here to 40, but because each of the nodes there, the time is not fixed. That okay? Because still there are something more. What? Because the time have up for the each nodes, including something uncertainty factor there, and this is reduced, just reduced to 40, but the probability of reducing of realizing it in 40 weeks, it may be very low, you know, because of the uncertainty of the time or something, of the calculation for the duration of this. So many things that is dangerous. Is that okay? Just $10,000 dangerous to realize this. Of course, an example that should not. It's not really nice, but realistic in the real situation. You complete the project is very good already. You think of you get some penalty. Oh my God, very hard. the people sign contract with you and tell you that you have some bonus if you finish before the deadline, but they calculate already everything. It's quite strict, very hard to. Uh, so everything. Hey, Uyên, turn on your mic.
Yes.
I just mean I see you turn on the mic and make some noise. Some people talking with you or something. I don't know.
I'm in the school library, and there's some other in the same table, and I mistakenly touch on the iPad. I'm sorry.
Yeah. Okay. Turn on your mic. So you see, until now, I tell you all, and Mr. Perry conclusion after calculating that, the conclusion is no, not try to reduce the time. Is that okay? 44 weeks is okay, and it's quite sure that you get in time, because the probability of completed in 47 weeks is 85%. That is okay. That's quite high. And actually some more things because in the book they still have some more things, but I think that is we should finish here. And something I write here, I explained to you already. That's so nothing but using the linear programming to make a crash decision. To make the crash decision here, I tell you that you have a critical path, and then you can list the paths. Is that okay? 5, 6 paths, and then you can reduce like this. But if you have the large project, this project have about 10 activity or something like this, is quite easy. But in the case you have 50 nodes, and then even the way you find out the paths, all the paths, is also very hard. Okay, and so this way is not the nice way. The way you see that the way we find out this one, and that in each node of this we have to work with the table like this. We choose the small little one, and then we list all the paths here, all the paths, and we do this like this. We do it all by hand. Is that okay? And this is just available for the small project, not big. And I just want to teach you to let you know the idea. That okay? And for the last project, we should use the method here. We should transfer the problem to a problem of linear programming and solve it by the simplex method, by writing program and by in some language, some kind of language, and then run it by the computer. Is that okay? That is in the last case. But the idea, I just give you the idea, and hope that with some small project you can use this way. In order to make the topic, I just want to ask you. You use in our program. You before this course, you learn about the course programming with C++ already. Some programming with some language, or the course called, I don't remember exactly the name of the course, but C++, or something like this.
Yes. But we are familiar with R or Python more.
No. I don't care. I don't care with Python or anything. Just you know, one language is okay, because I don't ask you to write down program with language. I just want you that you know how to program. You know, for example, if, then, or something. Just the logic. I mean, just the algorithm. You know. Step 1, what you do. Step 2, you do what. Step 3, you do what. That's all. Like I see that in the optimization 2, you know. Optimization 2, we learn a lot of algorithms. Step 1, step 2, step 3, or something like this. You just understand it and imagine in your mind how to realize this with some kind of language. That is okay. Okay, I will think of. I know this, and I will think of some topics and introduce to you next week. Now it's okay. I think just 3:10, but this is the end. Let me see that. Network model. What is it? Task. And here is the Gantt chart. I'll tell you. In the file, the files I send you, like this chapter, many other chapter, not only this chapter, but in each of the chapter like this, you see that some in the book they have some something like this. Torah moment. Torah is the software, and this software can be used to solve the PERT, to find out, to write down the Gantt chart. Some years ago, I asked one say TA of the Department of Mathematics, who is a student of our firm, and then finish the course and stay at the department. She have you to do like this, but very easy. That's so I don't want to teach you this one. It take time, but it's easy. It's like a Microsoft Word, Microsoft Excel, or something like this. So in your life, when in the future, when you work with a big project, you can use some software like this. Is that okay? To solve the problem, and how to solve it, very easy. You, for example, here they just write a very short instruction. You have this software, you can use it to run this very fast. But we our university, we don't have officially like this. So the last time, some years, about 2 years ago, I asked the TA. She downloaded some okay, maybe illegal or something like this to give it to the student to make it, but it's not so nice because it's not legal program. And another one is just give you some graph like this. Let's see. And the TA, because she also have much time and not forget, we are not familiar with that, and then didn't give the student much interesting things. So I think that when you go to work, you can check some program like this, and you can work with this. Okay, that is a worksheet of the program. It's very easy. And so my idea is that you learn the algorithm or how to program in some kind of language, and so you just know the idea. Mathematics student is just the strong point is the idea and the way how to solve it. And if you get some other problem, you can modify it to solve that. That is the key point. So about the algorithm, about some software like this is quite easy, like Excel. Like Excel, you also can use Excel to solve linear programming, and also solve this one, I think so. But so it's easy. Okay. As last time I tell the TA not use this one. Not Torah. She found some like MS, that Microsoft, but special like Excel, but Microsoft MS, I don't know, MSQ or something like this. It's now I think that's a lot of the software that can solve this problem. Okay, but it's the same like I tell you. If you have the game with the matrix already, then it may have some software help you to solve it. Many methods, don't care. But the problem is, you have the problem. How you can transfer this problem, model it into the mathematical model. That's trouble. And that need you, student of firm, financial engineering. You learn a lot of math tool, you learn how to reason, and learn a lot of ways thinking or something like this. Then you can do that. Using this one, teaching you use this one, the student in BA also can do that. When you go to work, they have some model and they can use this to do that. But if they get some problem, which is a bit different from this one, then you can do that, but they cannot. You see, you can use your knowledge to modify, to make a modification for the math model, and then you can solve it. But the other cannot. And this one, very easy, and it's not necessary for the student of mathematics use software like this. This leave for the BA student. Okay. Okay, this time. Okay, the class is ended here. Next week, see you next week. And next week I will introduce. We will arrange the group. We will have a topic or something like this. Distribute the topic to the students, to the group. Okay. So we stop now. See you next week. Yeah, stop. Okay, bye-bye.
Bye bye thầy.